Hi, welcome. This is a lesson on factoring quadratics with a greatest common factor. So the steps, which are the same as what we did in our last lesson on factoring quadratics, are to one, make sure that the expression is in standard form. That's ax squared plus bx plus c. To factor out a GCF if you have one. We didn't really have one in the other class. We talked about it, but now we're going to see examples when we have a greatest common factor. And then 3, find the values of A, B, and C. A is the coefficient of the x term. B is the coefficient, A is the coefficient of the x squared term. B is the coefficient of the x term. It's just the number that comes before the x. And then C is typically a constant. And so step 4 is you multiply A times C. And step 5, find two numbers that multiply to A times C and that add up to B. And then you either use the box method or grouping. And so in the box method, you fill in your box with P and Q being the two numbers that you found in step 5. And so we put an X with them. AX squared plus PX plus QX plus C. And then find the sides. A number there is the greatest common factor of this row, and the number there is the greatest common factor of this bottom row. In this column, the greatest common factor we would write up here, and for this column, we'd write the greatest common factor up here. And this will make more sense when we go through and do an example. All right. And then in grouping, you can rewrite bx as px plus qx. So these two are the same as your bx, your term, your middle term, and P and Q are the numbers from step 5, so this is a different way. And then we factor by grouping like we did from lesson 3.2. Group these two together and find the GCF of each of those groups. And we'll see examples of both of these here in just a moment. So example 1, the first thing we want to see is in standard form. It is factor out a greatest common factor, and I look, they're all even. The smallest number is 4, and 4 will go into 8, but it won't go into 18. And so then I go to 2, and I say 2 times 2x squared plus 9x plus 4. And taking a 2 out of each one of those terms. So 2 times 2 is 4, 2 times 9 is 18, and 2 times 4 is 8. So now I'm just considering the part inside the parentheses. And so I say AC is 2 times 4, or 8, and B is 9. And I look for the numbers that multiply to 8 that add to 9. And I always start with 1 times the number. 1 times 8 is 8. 1 plus 8 is 9, so I found it right off the bat. So I'm going to choose to use the box this time. And once again, I'm using these values, not the ones above. So I'm just factoring what's in that polynomial after factoring out the 2. So I put 2x squared here and plus 4 down here. And the 9x, I'm going to put in using the numbers that we found, 1 and 8. So I'm going to put plus 1x and plus 8x. And then I'm going to factor each row in each column. 2x squared and 1x have an x in common. And 8x and 4 have a 4 in common. So I'm going to put plus 4 here. And 2x squared and 8x, they share 2 and an x. And then 1x and 4 don't share anything in common, so they always have that one factor in common. And so then I just go through and I double check to see if when I multiply these, 2x times 2x is, 2x times x is 2x squared. 1 times x is x, or 1x. 2x times 4 is 8x. And 4 times 1 is 4. So everything in this polynomial here oops, let's see, that's plus. So everything in this polynomial here is represented in the box. And so my factors are 2x plus 1 times x plus 4. This is the x plus 4, and this is the 2x plus 1. And I need to make sure that I remember that 2 right there that I factored out at the beginning is one of the factors of the original expression. So I need to put it in as a factor as well. So it's 2 times 2x plus 1 times x plus 4. So once you've factored out your GCF, then you need to make sure you put it in the end. All right, let's look at example 2. So 9 is the smallest number, but 9 won't go into either 39 or 30. But the next biggest factor of 9 is 3, and 3 will go into both 39 and 30. So I'm going to factor out a 3. But because it's negative 9n squared, our leading coefficient is negative, we want to factor out a negative. So that's going to be negative 3 times 3n squared minus 13n. Sorry, that's not going to be minus, it's going to be plus. Plus 13n, because a negative times a positive is negative. And then it's going to be minus 10. Again, a negative times a negative is a positive 30. And then my values of AC are 3 times negative 10, or negative 30. And B, my middle term, the coefficient is 13. And so I say 1 times 30 is 30, but I want it to be negative, and I want the value of B to be positive, so I'm going to put the positive on the 30 and negative on 1. So negative 1 times a positive 30 is negative 30. Negative 1 plus 30 is 29. And that's not it, but we've got the signs in the right place. So negative 2 times 15 is negative 30, and negative 2 plus 15 is 13. And those are the numbers that I'm looking for. So this time I'm going to factor this out. 3n squared minus 2n plus 15n minus 10. And these two numbers here came from minus 2 and 15, and they are the same as 13n, because negative 2n plus 15n is 13n. And then I just grouped them together. So, and maybe I should have shown that's what I did after. So that's the same expression as what I have inside the parentheses. And now I just group those together. I'm going to forget about my minus 3 for a second here and just work with what's inside the parentheses. So then I've got an n that I take out, and that's 3n minus 2. And here I've got 5, so I'm going to factor out 5 times 3n minus 2. And then I have that common factor of 3n minus 2. I can factor that out. 3n minus 2 times n plus 5. And the minus 3 that I'd factored out at the beginning, I can tack that on to each number along the way, to each part along the way, and just include it in my final answer. Minus 3 times 3n minus 2 times n minus n plus 5. All right. For number 4, once again, I see that they all have 3 in common. So I factor out, this time, a negative 3. So negative 3, same as the last problem, actually. Negative 3 times 2y squared minus 13y and plus 15. And now my AC is 2 times 15, or 30, and B is negative 13. So now I'm looking for two numbers that multiply to a positive 30 that add to a negative 13. And this time both numbers will be either positive to get a positive result, or both negative. And since B is negative, that means they're both negative. Negative 1 times negative 30 is positive 30, but add to be negative 31. Not what we're looking for. So negative 2 times negative 15 would be positive 30. Negative 2 times negative 2 plus negative 15 would be negative 17. Not it. 3. Negative 3 times a negative 10 would be a positive 30. And negative 3 plus negative 10 is negative 13. So those are the numbers we're looking for, negative 3, negative 10. Now, the last time we did without the box, I'm going to do this one with the box again. I'm going to put 2y squared plus 15 in the last box. And then in these two boxes, I'm going to use the numbers that we found, 3 and negative 10. So that's negative 3y and negative 10y, because negative 3y and negative 10y are the same as negative 13y when I add them together. So 2y squared minus 3y, factor out a y. Negative 10y plus 15. I'm going to factor out negative 5. 2y squared and minus 10y, they both have 2 and a y. And negative 3y and 15, they both have, let's say, negative 3. Now I'm going to adjust for the signs there if I need to. 2y times y. Let's use green. 2y times y is 2y squared. Yes. Negative 5 times negative 3 is a positive 15. Yes. 2y times negative 5 would be negative 10y. Yes. And y times negative 3 is negative 3y. So yeah, everything in there is a result of those multiplications. So we can say our factors are 2y minus 3 and y minus 5. Once again, it's important we remember that minus 3 that we factored out at the beginning. We're going to include it as one of the factors. So minus 3 times all of that. All right, that's example 4. All right, now we're going to talk about difference of squares. Factoring. When something is in the form a squared minus b squared, where a and b are perfect square expressions, the factored form looks like a minus b times a plus b. All right, so what do we notice about the factored form? Well, it looks like it's the same. I see a and I see b. I see here a and I see b. So they're the same, a and b and a and b. But one of them is a minus and the other one is a plus, and otherwise they are the same. All right. So let's notice Oh, and in their squared form, I'm sorry, when they're multiplied together, they're both perfect squares. A squared and B squared are perfect squares, and a difference means subtract. And so you have a difference of squares. That's why we call it a difference of squares. All right. So we've got x squared minus 49. And I can rewrite this as x quantity squared. I didn't really change anything there, just put it in parentheses. So you can see that the value of a is x minus 7 squared, because 7 squared is 49. And because I've now written it as in the form a squared minus b squared, now I can just say, hey, this is equal to this. So they're the same, right? X and 7, X and 7. That's like my a and my b, a and my b. But one of them is plus and the other one is minus. So x plus 7 and x minus 7 would give us that x squared minus 49. Let's look at 6. Now, example 6, at first glance, you might say, oh, well, that's not a difference of squares. But actually, it is. We can rewrite 9x squared as the quantity 3x squared, because that'd be 9. 3 squared is 9, and x squared is x squared. And then I've got minus, and 16 is the same as 4 squared. And so really, this list of perfect squares is going to be your friend to recognize the perfect squares. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. And you could go further, but I'll stop there. And then the numbers that correspond with them: 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So the two that I see right off the bat that have to do here is 16 and 4, and 9 and 3. All right. So now that I've written it as a difference of squares here, I can then go to this and say, okay, I've got two pairs of factors that these are going to look like: 3x and 4, 3x and 4, but one of them is plus and the other one is minus. And so that's what this looks like factored. All right, let's look at number 7. 25m squared minus 36n squared. They're trying to throw us by putting an n on the end there. But we recognize 25 and 36 as being in our list. "25 is 5 squared and 36 is 6 squared. And so I can rewrite this as 5m squared minus 6n squared. And then I can rewrite this as 5m and 6n, 5m and 6n, but one of them is a plus in between them and one of them is a minus in between them. All right, look at example 8. All right, in example 8, I've got a difference of squares that I can recognize as being 4s squared minus 6t squared. And then I can rewrite my two pairs of factors of 4s and a 6t, 4s, and a 6t, and one of them is plus, and the other one is minus. And that does it. Make sure that you practice. You'll do fine. Have a good day.